Alright, this is Ken Rosever. We're going to talk about the curious die, which is one of the more difficult problems that they have in Alex, but it's not crazy. Okay, first of all, a peculiar die has the following properties. Normally a die has a uniform distribution where you have a 1 in 6 chance of rolling any of the numbers, but this one's kind of weird. It says on any roll the probability of rolling a 3, 6, or 2 is a half. Well, that's normal. Your chance of rolling any selection of 3 numbers on a typical die is a half, because 3 out of 6 is 1/2. Just as with the ordinary die. So moreover, the probability of rolling a 2, 1, or a 5 is also a half. So we have P of 3, 6, or 2 equals 1/2. P of 2, 1, or 5 equals a half also. However, the probability of rolling a 2 is 1/8, not 1/6. So notice with me real quick that 2 is the intersection of these two events. So what they're telling me here is that that intersection, which is 2, there's only a 1 in 8 chance of being in it. Okay, now the question is, from what you know about this peculiar die, compute the probability of rolling a 3, 6, or 4, and the probability of rolling either a 3 or a 6. So we're going to work this out. We'll call this P of A, and we'll call this P of B, and we'll look at this as P of A intersect B. Therefore, event A and event B are not mutually exclusive. They do overlap. Okay, here's what I want to say. This is A, this is B. We have a half shot of being in either of these. We have a 1/8 shot of being in here. So if we take away the 1/8, then this must be 3/8, and this must be 3/8 as well. How can I prove that? Well, I can say A is composed of regions 1 and 2. Well, region 1 plus region 2 has to add up to 1/2. But region 2 is a 1/8. Therefore, using simple algebra, 1/2 minus 1/8 is 3/8. So that's how I get that, and likewise that's how I would get that B is 3/8. So that's very simple. Inside here we have the numbers 3 and 6. 2 is inside here, and 1 and 5 is inside there. So where's 4? 4 is out here. And if we add up all this, we get 7/8. So if we have a 7/8 chance of rolling these 5 numbers, 4 is the only number left, so we have a 1 in 8 chance of being out there. So they want to know, what's the probability of rolling a 3, 6, or 4? Well, you can see that if we have a 3/8 chance here and a 1/8 chance out there, and you can't roll both, right? They're mutually exclusive, so we just add up 3/8 and 1/8, and we get 1/2. So the answer here is 1/2. Alright, what's the probability of rolling a 3 or a 6 alone? Well, we answered that right here when I drew this arrow, and that's a 3 in 8 chance. So we have a 1/2 chance and a 3 in 8 chance. And let me put those in now. 1 divided by 2, and then 3 divided by 8. We'll do another one. So I'm going to practice again. A peculiar die has the following properties. So on any roll, the probability of getting a 6, 5, or 1 is a half. So 6, 5, or 1 is a half. The probability of rolling a 1, 4, or 3 is a half. So the intersection is a 1. So I'm going to draw, actually, how can I do this? Make it a little neater than last time. Okay, in the first circle, which I will call A, we're rolling a 6, 5, 1 is in the intersection, 4 and 3 is over here. So these are the various values you can roll. So therefore the one we're leaving out is 2. Now if we have a half chance of rolling any of these, P of A equals 1/2. P of B equals 1/2 as well. But the probability of rolling a 1 is 3/8. So therefore, it's the easiest way to think of it. Region A is composed of 1 and 2. So P of A is equal to P of 1 plus P of 2. Our chance of that is 1/2. P of 1 we don't know, region 1, but we do know P of 2, they just told us is 3/8. So by subtracting again, we have a 1 in 8 chance of rolling this. And similarly, we do the same here. So the probability there is 1/8. Let's do a little erasing. Probability here is 1/8. And the central probability is 3/8. When you add these up, 1/8, 3/8, and 1/8 is 5/8. The whole thing has to add up to 8/8, which is 1 whole. So that means the probability out here is 3/8. By the way, it always comes out that these are symmetric. What's the probability of rolling anything but a 1? Well, it's 8/8 minus 3/8 is 5/8. What's the probability of rolling neither a 4 or a 3? So we don't want to roll a 4 or a 3, so that's a 7 in 8 chance. That's it. 5/8 and 7/8 are our answers. We put them in here. 5/8, 7/8. That's it. Let me see if I have to do one more. Very good. Yeah, one more. Okay, and then they'll add it to my pi. So here we go. A peculiar die has following properties. On any roll, the probability of rolling a 2, 3, or 4 is a half. Moreover, probability of rolling a 4, 1, or 6 is a half. Look what's in the overlap. It's a 4. Okay, the probability of rolling a 4 is 5 out of 16. Okay, this is my Venn diagram. Not as pretty as last time, but oh well. 2, 3, 4, 1, 6, 5. We have a 1/2 chance of being in A. So P of A is always 1/2. P of B is 1/2. Okay. We have a 5 in 16 chance of being in the center here. So that's a 5 in 16. And when you go 1/2, which is equal to 8/16 and minus 5/16, you get 3/16, which is the probability of this one or this one. So, and then when you add, if you add 3, 3, and 5, you get 11. 11/16 subtracted from 16/16 leaves you with a 5/16 out here. But just as I said before, this guy in here will always match this area out here. Okay? So, find the probability of rolling a 5, 1, or 6. Well, that's a half, right? Because if I do it with this number, it's 5/16. If I do it with the 5, it's 5/16. It doesn't matter if I pair the 1 and the 6 with the 4 or the 1 and the 6 with the 5. I still have a half chance. So the answer there is 1/2. The probability of rolling anything but a 5, 5 is out here. It is valued as a probability of 5/16. So not rolling it is 11/16. So it's 1/2 and 11/16, and we're done. So, and that'll add that to my pi. Hopefully that helps you guys out. Make a Venn diagram, it helps. Bye-bye.